In this question, we're going to have a look at using the chain rule from differentiation and also finding the equation of a tangent. So just a little reminder from year 1 maths. If you have a random curve and you have a tangent that crosses the curve, what that means is that the tangent follows the gradient of the curve at that point. Meaning if you find dy by dx and you substitute in the x coordinate at that point into dy dx, you actually get the gradient of the tangent because it's the same as the gradient as the curve at that point. So let's break that down. Dy dx. Before I go further, I'm going to tell you how you can spot that you use the chain rule in this case. Whenever you have a function, like let's say x cubed or even x plus 5 inside of x cubed, we call this a composite function. It then becomes x plus 5 all cubed. Whenever you do have a composite function and you want to differentiate it, use the chain rule. That's actually what we have here. We have the function of 3 minus 2x inside of ln x. One last reminder, ln x actually just differentiates to 1 over x. That's going to be important for this question. Okay, let's combine everything that I've been talking about so far. So first we're going to differentiate y with respect to x. So 2 differentiates to 0 plus, and then you want to differentiate ln 3 minus 2x. Let's do that to the side a little bit. So when using the chain rule, whatever's inside the bracket, you call that a singular letter. So you say let u equals 3 minus 2x. And then you make this whole equation in terms of u now. So we get y is equal to ln u. From here, you can find du by dx, which is what you get when you differentiate this equation here with respect to x. So that will be minus 2. And from here, you can find dy by du, which is what you get when you differentiate ln u. Because it's just a singular letter, it will just differentiate to 1 over u. Dy dx is then written out as dy by du multiplied by du by dx. The reason why this works is because the du's on the top left and bottom right will cancel out, leaving you with just dy dx. We found these individually. We found dy by du is 1 over u, and you multiply onto that du by dx, which is minus 2. So that's equal to minus 2 over u, which is 3 minus 2x. So that's it. That's what dy dx is. We can now add it onto this. So it's just minus 2 over 3 minus 2x. That's dy dx. And we're trying to find it at the point when the x coordinate is 1. So you can put x equals 1 into this to actually get the gradient of the tangent. Because just a reminder, dy dx gives you the gradient of the tangent. So it's minus 2 over 3 minus 2 lots of 1 when you substitute x as 1. 3 minus 2 is 1, so that's minus 2 divided by 1, so just minus 2. I mentioned before the tangent is a straight line, which means that its equation is in the form y equals mx plus c. We've done the part where we found the gradient of the tangent is minus 2, so let's substitute that in. Y equals minus 2x plus c. Now we need a coordinate that the tangent crosses through to find the value of c. Well, we know that the tangent intersects the curve at that specific point. So if we put x equals 1 into the equation of the curve and get the y coordinate, that's the same as the y coordinate that this tangent line crosses through. So let's do that. So let's do it here. When x is equal to 1, the curve y is equal to 2 plus, ln of 3 minus 2 times 1, which is 2, so ln of 1. ln of 1 is actually just equal to 0, and 2 plus 0 is 2, meaning that the point P is actually just 1, 2. If you replace x with 1 and y with 2, you get 2 is equal to minus 2 plus c. Add 2 to both sides, so c is equal to 4. Finally, you can say that the equation of the tangent is therefore y equals minus 2x plus 4. And that's everything for this question. Hopefully it all made sense, and if you have any questions with it, just let me know in the comments. Otherwise, please like the video if it helped, and be sure to subscribe. I'll post more videos like this in the near future.